The single component material node represents the specific type of substance being modeled. The air node exists within the gas model node since air is the default gas type when the gas material model is selected. The type of material defaults to air if we are using gas model, water if we are using liquid material model, and aluminium if we are using solid material model. A node with a corresponding name appears with properties and a pop-up menu. We can rename this node using standard techniques. We can also replace the type of material used. It is also possible to set material properties. To replace a single component material, right-click the node of the existing material type and select Replace With. Then, select a replacement material from the list in the Replace Material dialog and click OK. The node of that selected material appears in the place of the default material node. The Material Properties Manager node is a central space node for the properties of a substance. This node is empty until either an equation of state model or a viscous regime is selected. After selection, it becomes populated with material property nodes. After the selection of an equation of state model or a viscous regime, the Material Properties Manager node becomes fully populated with material property nodes. This can be accessed through their properties. We can use various methods for material properties. Let us see them one by one. Generally, most initial conditions are specified as constants. This value is entered as a scalar value in the properties as shown for specific heat. Field functions can be used to create non-standard functions for material properties. Suppose that a scalar field function that is called conductivity air is defined as given by this equation. This field function would then be selected in the list corresponding to the scalar function property in the properties window. This polynomial function is available for certain material properties. The properties for this function are set in the properties window. Thermodynamic polynomial data provides 5 coefficient polynomial curve fits for data read-in from the selected material database. The Chemkin database file thermdat.dbs is essentially a text file and can be modified with any text editor. The IAPWS IF97 specification is available for various material properties. This method node has no properties. It acts simply as an indicator that the associated material property follows the IAPWS IF97 specification. The Sutherland's law function is available for various material properties. The coefficient properties for this function are set in the properties window. Sutherland's law for viscosity is shown here. In this, equation T0 and μ0 are the reference temperature and viscosity respectively, and S is the Sutherland constant. Also, we can see the Sutherland's law for thermal conductivity. In this, T0 and K0 are the reference temperature and conductivity respectively, and S is the Sutherland constant. The power law function is available for various material properties. The coefficient properties for this function are set in the properties window. As shown here, the power law function for viscosity is given where T0 and μ0 are reference temperature and viscosity, and n is the power law exponent. Also, the power law function for reference temperature is shown here, where T0 and K0 are reference temperature and conductivity respectively, and n is the power law exponent. The volume weighted mixture function is for non-ideal gas mixtures. The volume weighted mixture equation is shown here. The mass weighted mixture method calculates a given mixture property by mass weighting the component property values. The equation is shown here. Next, we have the anisotropic method. The anisotropic method is the node which has the information about anisotropic approach to thermal conductivity. This method is available for the thermal conductivity material property of a solid when the coupled solid energy or segregated solid energy model is active. What is the Material Database Manager? The Material Database Manager is the method by which *CCM Plus provides easy access to information on a wide variety of substances from accurate material modeling in the simulation. For working with Material Database, we have to go to Simulation Tree, then Tools, and then click on Material Databases node. In *CCM Plus, there is a node called Material Database. The Material Database node is located within the Tools, Material Databases node. It contains the objects that represent the information from the Material Database. When you create a simulation, this node appears with its subnodes in the object tree as soon as you select a material model. Its contents are grouped among 3 subnodes that represent database folders, which are gases, liquids, and solids. You can also create database folders as well as create database material properties. The source of the material database is a props mdb file. This is located in your main *CCM Plus installation directory. A second material database is supplied called props.ext.mdb, which contains a larger selection of materials that are rarely used. What is the material database folder? A database folder node contains database materials. In the default standard material database, these folders are used to group database materials as gases, liquids, and solids. Then we also have database material in *CCM Plus. The database material node represents the substance in the material database. Simply saying, this is material. It is a node for database material properties nodes. The nodes of these materials have subnodes representing database material properties such as dynamic viscosity and molecular weight. The database material property node represents a particular property of the substance in the material database.